So from here, I like to start with opposite of our input for power. We need our pads to connect to our foot switch and our input and output jack. So we have our in pad, our out pad. Here's our ground pad. Here's L minus, that's going to connect to the LED to connect to the switch, so it connects to ground, so it turns on when you turn it on. And we also have this random unnamed pad, which is our buffered out, in case we want to use this as buffered bypass instead of true bypass. And I usually order these in, ground, LED, and out, but having the extra buffer thing in there, I'll probably just throw that in the middle. So we'll do in, ground. This is the buffered out pad. We can double check that by clicking the info button and clicking on it. B, yes, that's what we named it. So we'll add a actual name for that later. That'll show up on the silk screen. All right, and then I keep all the pads generally, especially here, on a 0.1 inch grid basically, and we're in 0.025, so that's 4 of those equals 0.1. So 1, 2, 3, 4. Or if you don't have your grid up and you want to measure something, above the DRC button is this dimension. This will allow you to select a point and then measure it from there to another point. So it's basically a measuring tape from here to here. That's it's default in millimeters, but 2.54 millimeters is 1/10 of an inch. So these should all be, yeah, these are all good. All right, and if you click on it, then you can move it out, but we just needed to double check it, so just hit escape. So now that we have our pads for hooking up jacks and switch, we can group those just like we did in the schematic. Use the group tool and just select what you need, and then click on the move tool, right click, move group, and then we can line it up. This is where the grid is kind of nice because you can kind of tell where center line is. Had I not deleted the enclosure, we would have seen where the center line was on. So maybe don't delete your enclosure as early as I did. But the other way you can tell is, okay, this is centered, and you look up here at these numbers, and center is 0.975, and this should be right on center, and it's 0.975, so we should be good. So that's all centered. Zoom to fit, that helps when you get zoomed in, and then you can grab a part as you need it. Now, when you begin to start placing parts, there's a couple different ways you can do this. Some people like to line up all their parts and then run all the traces, which is fine. It's a perfectly plausible way of laying stuff out. I tend to place a few parts and then run traces, or I don't get too set on a certain, like, okay, all the resistors have to be lined up right here and all the capacitors in the next row, and then etc. That can lead to some really weird and long traces, which isn't necessarily a huge no-no, but it's generally best to keep your traces on the shorter end to avoid any interference. But I do like to keep things looking fairly symmetrical, but for a beginner, I wouldn't get too bogged down in making it look overly symmetrical. And the key thing is to keep things buildable. You don't want something that's got overhanging capacitors over a whole bunch of resistors, or having just weird parts, because it's just going to be a pain in the butt to actually build. So I generally will start with, in this case we've got an IC, so here's our dual IC. Again, you can click on something and rotate it with right click. and this is kind of like the heart of the circuit. So a lot of it is happening around this. So this is probably pretty doable. Just slap in the middle of our board, and then work around it as we go with resistors and capacitors. And once you place a part, you don't always have to, but I tend to hit the rat's nest so I can see that the pads there have been room made for the pads in our planes. And from here, I kind of want that, and I want our resistors to be on the sides. It doesn't really matter if you have your resistors like this, and you can mix them. Well, it's not lined up. You can have some like this. I like to keep them going, all the same orientation, but I don't get too, stuck to that if I don't need to. If I can save board space and save myself from having to run some more crazy traces, I'm gonna defer to something that's easier to place than necessarily symmetrical or as aesthetically pleasing. So at this point, when we're looking at our schematic, we can we know, okay, we got our pull down resistor and our input capacitor going into this MOSFET gain stage / buffer. And so we will start placing some parts and getting to where we can put Q1 down. So we'll swap back to our board and we'll grab R1. This can probably go, it's going straight to ground from in, so we'll just put it right by the in pad. And if we hit rat's nest, hey, it's already connected to ground. There's a connection we don't even have to route already. And then find C1 and place it right next to that. And a lot of this is really just kind of playing around with part placement until you find something that really sticks and really makes sense. If you accidentally grab onto the name of something, just hit escape. Zoom in a little bit closer. You can see the origin of the text is just below the origin of the part. And that will vary depending on your library. There's no set way that people just do it. It's kind of designer's choice, I guess. We could put R4 up there because it's just going to ground, but it connects to this pad, which is the source of the MOSFET. So I'm going to use the group tool and kind of move things around so that can be a little closer to that pad. And another way, you can group things like that, or you can make a customized path of what you want to group. So if you need to, avoid a few other components, you can do that with just by clicking it instead of click and drag. So as you can see here, I've got the first 7 components down at the beginning of our circuit. I'm kind of liking the way how this is starting to look. At this point, I'm going to start laying out a few traces, and again, traces are subject to change. Don't feel like I've got this placed, it's permanent. It's definitely not. There's the rip up tool, and I use it plenty. So we're gonna select our route air wire, which means these yellow lines, we're going to make them into traces with this. Again, up here, we want to tell it what layer we want to do that on, and our choices are either the top or the bottom layer. Top is fine. Our width we'll leave at 0.01, This is for if you need to change layers mid-trace without connecting to something. It will create something called a via, but we're going to try to avoid those two because they're like jumpers, and if you followed my blog for a long time, you know I don't really like those. Okay, this drop down again is the how the wire goes, and for traces I like the 45-degree turn. So I'm going to start at this in pad, click on the origin of that, and you can see it. This is where the trace is going to go. Click to connect, and then over here, rat's nest. Hey, we've got a trace. Now you can follow the air wire. Okay, this goes up to C1, and we're going to route that trace as well. There we go. Now this goes into the base. I'm sorry, the gate of the MOSFET. Connect that. It's really just connecting those thin yellow lines and making sure everything connects. And you'll see as you connect components with traces and you hit rat's nest, it shows you how many are left, and we've gone down. We used to have 68, now we're down already to 56. So it's nice. It's a nice little progress indicator that you're actually doing stuff. Now, when you're running a trace, and say you want it to go around that pad, but you don't want it to go that way, you can right-click, and it will change how the trace is being formed. Another thing you can do is if you are, say you're running a trace from this pad and it needs to go up that way, you can just do a 45 and right there on that curve. But if you need to change this on the fly without having to come up here and click on it and change it, what you can do is start your trace and hit control and then right click, and it will change it. See, now I've got the diagonal, and click it again with control, and now I've got a slight curve, and then again, and I've got a 90-degree curve. And I can just come up there like that, and that leaves a lot of extra of the voltage plane there, so we're not cutting off too much. Just a little trick there that I use frequently. Oh, and here comes where the rip up. We don't need that here. All right, back to laying down traces. One thing what I want to do at this point is not for it's easy to go through your schematic and just go by the numbers R1, C1, R2 and go all the way through, and then you reach the end and you've got your audio path all figured out, but you've forgotten about your power supply sections. In this case, I'm worried about the VA voltage reference with R15, R16, and C11. They only go to one spot, and that's to R2, and I don't want that connection to get buried here, and then later, once I've got all the audio path laid out, all pretty, that now I have to do surgery and insert those three components somewhere that makes sense, that's not too far away, and I don't have to do some crazy traces and then some weird vias and all that nonsense. So I'm going to go ahead now and grab R15, R16, etc., and place those where it's convenient to connect to R2. If you do accidentally click on the label, you can right click before you start moving. Right click, it kind of asks you, oh, is this the one you want? And if it's not, it's how the R16 is highlighted. If you right click, then it will change what is selected, and then once that's correct, you can then left click again and then grab and move the component. park that there for now. Again, it's highly likely that half of this stuff will all move. One thing I like to do for the voltage references is increase the width of the trace a little bit. I don't really have any scientific reason for doing that. It's just kind of this kind of makes sense in my head. It might be dumb. Someone will probably tell me it is dumb, but that's what I do. And it's not been a problem. Alright, so I kind of want to put this over here in line with the transistor and that cap down there, but that's just too close. So like I said, nothing is permanent. Let's go ahead and group this and move it over a little bit to give a little bit more space, and that should be fine. Now you may be wondering, should I put all my traces on the red layer, on the top layer? No, I usually start there and try and put the majority of my traces there, as it's more important for there to be more ground pad than, not ground pad, ground plane than voltage plane. But they still need to be somewhat similar in size. But I'd rather break up the voltage plane a little more than the ground plane. So when I switch to the blue layer, the back layer, it's when oh, that doesn't go there. Huh. This goes around. So when I switch to using the back layer is just as needed. Like I try and do probably the majority on the top layer, and then this needs to get voltage somehow. So if I put a red trace, a trace on the top across this way into here, it's going to make it more difficult for that pad to stay connected, and then you'll get an air wire and you'll have to connect that. So it's if you can think ahead a little bit, oh, that's got to still maintain connection. Yeah, it's connected now, but it will it still be if I run a trace on that same plane that might block it off. That's when I will switch to the back. And the same goes if you're on the back layer and that's going to cut off ground to something, and it's probably best to change which layer you're working on. Another little tip: having traces cross each other is inevitable in a dual layer board like this, but it's best really to try and have them cross at 90-degree angles like that as much as you can. You can definitely get away without doing that. Like here they're at a 45-degree, and that's probably going to be fine, but ideally try and cross at a 90-degree angle, and you really don't want, as much as you can help it, traces going like directly over each other. One on the back, one on the front, can lead to some not so great things. you might be asking, why'd you just move your pots around? This is bugging me. I know I said don't get hung up on the aesthetic of it too much, but it's bothering me, and I'm going to do exactly what I told you not to. But it shouldn't really hinder anything design-wise. It's just going to make me reorganize some stuff, and gives a little bit more room for capacitors. They're all more in a straight line over here. I don't know. I may go back and change it. Who knows? Now, if your eagle starts looking like this once you've started laying out traces and stuff, and you see all these extra names on pads and traces, I have these turned off by default since I've upgraded from an earlier version where I've already set my settings to not show these things, just because they get cluttered to me. But if you like them, well, hey, they're there. You can. They are helpful in figuring out. Oh, okay, this is. Oh, here's my VA voltage reference point here. Oh, this pad goes to ground. Here's the cathode. Here's the anode on a diode. Those are great. But if it gets too cluttered, you can always turn them on if you need them. You can turn them off if you don't want them. Go up here to Options and Set, and go over to the Miscellaneous tab and turn off Display Pad Names, Display Signal Names. There's all kinds of things. Beep will, when you make a connection, it'll beep and show that it's done. It can get annoying. And I turned it off for recording. Show display via length. That's just showing it goes from pad or from layer 1 to the bottom, top to bottom, or whatever. Signal names on traces. I don't want. Yes. Okay. That's normally what I have by default, so that just makes it a little cleaner. But like I said, that's a personal preference, and it's up to you if you want.